Okay, so on the front of the heart, coronary artery, apex is down here, the point. This is the left ventricle, so it's quite large. The white tissue on top on the outside, this is fat. Fat protects the heart. It's supposed to be there to a certain level. Okay, then when you flip it up to the top, what you're going to see is you're going to see blood vessels. Like I said, the flat, squishy ones, those are going to be veins. Because these hearts have been compressed and pressed into a small area, they're not really out the way they should be. This is an atrium or an auricle. They look like dog's ears, one on this side, one on this side. Okay, so these are the upper chambers of the heart, and that's always a surprise to people because they really are very flat and don't really have much structure to them. So it kind of gives you an idea of what kind of work they do. The bottom part, like we said, are the ventricles, and then these are the atrium. And you think, oh my gosh, well, they're so small. How come they could be so small? These balloon out, and these to be reservoirs for the blood and push the blood into the ventricles. And the ventricles are the pumping portions that actually take everything out and into the lungs and out into the body. Backside of the heart, pretty uneventful. You can kind of see the stalk in there, but there's a lot of fat on these hearts. Okay, so the first thing we want to do is orient our heart. So the apex is at the front. We've got our coronary vessels showing there, and just lay it there like that. Okay, so turn off your, want to check your students to make sure they've got it in this orientation before you ever begin, so that they can at least identify the atria and the ventricles, the fat, and the fact that these little tubes on top that are as flat as pancakes are vessels that are leaving the heart. And the really large ones are going to be the ones that actually take the blood out into the body or bring the blood back in. Okay? And the smaller, that you can't really see very well, are going to be the branches that go to the lungs. And you can see those on the back here underneath all of it. I'm gonna get, again, try to keep your hand away from that blade. I think I've done it. I think I got them both. Okay.
And just cut around through the ventricles?
Yeah, you want to make it so you can get as much view as possible. Yeah, I got them both. Okay, so when you peel it open, what you're going to get, this is the left ventricle, and you can see how huge it is. It takes up the whole bottom half of the heart. And the upper one is the right ventricle. And this one's got some pieces of nastiness in it from just laying around. So you've got both of them showing. Now, you can also see, the cool thing is that I didn't completely destroy the valve. So you can actually see the valve. So you can see here are, let me give the orientation again. So here are your coronary arteries. So I turned it on its side and I cut down through the heart, down to the apex. The closer you get to the apex, of course, the more evenly you're going to see your tissue. But what you're going to see on the inside is you're going to see your left ventricle is enormous. And that's something you want to point out to kids. This is the part of the heart that pumps the blood to the entire body. And so making sure that they understand that. These little tiny tissue right here, these are all part of the valves. And so one of the things that students may not know is this chordae tendineae are these little tiny pieces. So they're the white pieces in here that actually make up kind of the parachute cord that holds on to each one of the valves in the heart. Those valves from pigs are actually used as replacement valves in humans. And so, and then the reason they do that is because this tissue is a special tissue. It's super, super smooth. It doesn't damage blood vessels. And because it doesn't damage blood vessels, it means that it's a tissue that works really well as a replacement tissue. And because of the way they can prepare it, they can make it so that it doesn't actually hurt the person or anything like that. Obviously, it hurt the pig that donated. But basically, the smooth tissue makes it so blood cells are not damaged as it moves through. Artificial valves cause a lot of damage to blood tissue, and so having a PIGS as a valve is a better way to go. Now, if you look in the right atria, or the right ventricle, you can see the same sort of thing going on. This one is darker looking in mine. I don't know how yours look. Do your little tiny chordae tendineae look darker too? Yeah, so yours are darker for some reason as well. And again, there's another valve in there, and that valve keeps the blood from flowing backwards up into the atria. And the atria right here, so this is the right atria, is right on top, okay, right above that right ventricle. Remember, right ventricle is the small one right here. So the blood comes into the right atria, goes into the right ventricle, leaves the right ventricle through the coronary veins, and when it comes into the coronary veins, it's going to go into the left atria, which is on this side over here. Okay, so right atria here, blood comes into the heart from the body. Left atria here, blood comes in from the lungs into this one, and then it travels into our enormous left ventricle. Left ventricle sends it out through the aorta on the top, and it sends it out to the body. Okay, so that's kind of the interior part of it. Okay, and you could go as far as teaching them each one of the valves in there, you know, and the different parts, chordae tendineae, you know, all of those kinds of things would be pretty awesome for them to know. You can stick your finger right through into the aorta. So you can go up from you can see it, you can go right up through there and stick your finger right through it. And the branches, there's a branch on that on the one side, and that's going to be one of the branches that goes up to the head of the animal. Okay, so yeah, you could stick your probe in there, or you can stick your finger in there. You can get an idea of. We should have some blunt probes. I didn't order blunt probes. We need some blunt probes probably to do a good job. Okay.
The dual scissors work too. That's
Yeah.
what we've been using.
Yeah, so you can stick a pair of scissors in there to take a look at it. Mm-hmm. Questions? Easy?
Yeah, one of the other things that David, I think was his name, had these kids do is start scraping away on the fat because they had time, and you can kind of see the veins a little bit better if you're really gentle in getting the fat off.
Yeah, you could, I mean, so yeah, you can remove fat and get right down to the heart muscle and take a look at it. Another thing you could do if you have somebody who's got some good microscopes is you can actually take a little tiny slice of this muscle and put it under a microscope and look at it. Same thing with brain tissue. We do have dissecting scopes. You could pull one of those out if you wanted to and utilize that. All right, so that one was easy. Not much to it.